Section 8.5 is on radical equations. In the first objective, we're going to look at solving radical equations. In the first example, solve the square root of x equals 2. We solve by looking at the opposite operation of a square root. This is the square root of x, so the opposite would be to square. So we're going to square both sides. So if I square both sides of this equation, I get the square root of x squared is x, and I get x equals 4. Okay, so to solve the above equation, we square both sides. Oops. Now there's a potential problem with this. Square both sides is the correct thing to do, but when I square both sides of the equation, I may have some interesting things happening. If I take and square both sides of this equation, so the square root of x squared equals negative 6 squared, I get x equals 36. And that's going to turn out not to be true for this equation, because if you take the square root of 36 as written, you do not get negative 6. Negative 6 is one of the square roots of 36, but it's not the principal square root as it is written. So this is not true. Okay, so squaring both sides does lead to some potential for extraneous solutions. So if I consider the equation x equals 3, I mean, it's a little equation, but if I square both sides, it gives me x squared equals 9. Now I know that x squared equals 9 has two solutions. That could be 3 or negative 3, but only one of those was true in the original. So you see we have our extraneous solution here. All right. Now, these examples right here were meant to show you that it's possible to get extraneous solutions, but because we chose very simple equations like x equals 3 and the square root of x equals 6, you were able to see right away that those weren't going to work. We're not going to be able to see that in most cases. In most cases, we're just going to have to check. Always check proposed solutions when we square both sides. Okay, very, very important to always check, because you're not going to be able to just look at it and tell that one of your answers is extraneous. Okay, so when I'm solving an equation containing radicals, if necessary, I want to rearrange first so that the radical is isolated on one side of the equation. I want it by itself. Then I'm going to square both sides, solve the result, and very, very important, we're going to check. Checking is usually optional when solving equations. It is not optional, absolutely not optional in radical equations. We've got a very good chance of getting extraneous solutions. Okay, so we must check. I can't emphasize that enough. Let's go ahead and look at the next example right here. When I square both sides, I'm going to square this. I'm going to get the square root of x plus 2 squared equals 3 squared. Okay, my radical was already by itself, so I was ready to directly square both sides. When I square this entire unit, since this square is over the entire expression, squaring it will mean there are two of them, so I just get x plus 2. Right, square and square root are opposite operations, so they're undoing each other there. So I get x plus 2 equals 9. Okay, and if I subtract the 2, sorry, I was thinking ahead, I'm going to get 7. If I subtract 2 from both sides, I get 7. Now, we have absolutely no guarantee that 7 is the correct answer. The only way to know is to go back and check. So let's go back and check. 7 plus 2 equals, the square root of 7 plus 2 equals the square root of 9 equals 3. That does check, so finally I will circle it and say that is my final answer. Alright, let's look at the next one. There are two radicals here. Okay, so we're going to make sure one of them is by itself. Doesn't matter which one. This one's by itself. So we're going to square both sides. Oops, I didn't mean to write a parenthesis. I meant to write my square root. Okay, so I've got 3 square root of x minus 1 equals square root of 3x plus 3. And we're going to square both sides of this equation. Look at the right-hand side first. The right-hand side, the square and the square root are opposites of each other. The square root is over everything, so those are just going to cancel right out, and we're going to get 3x plus 3. On the left-hand side, this square is going to affect everything. This 3 is not in the square root, so that 3 will get squared, as well as me squaring the square root. So we will get 3 squared is 9. times the square root of x minus 1 squared is regular x minus 1. So we had to make sure we squared both pieces because this 3 was not inside that square root. Okay, and this was a product though, so you can square a product by squaring each of the pieces. Remember, that's that property we had from chapter 5, that ab squared, or ab to the n, I think we did in chapter 5, was a to the n, b to the n. So it's okay to take something to a power if it's in a product. Okay, all right, continue just to solve as normal. So you would use the distributive property here. 9x minus 9 equals 3x plus 3. We'll start subtracting our 3 to the other side here. So 6x minus 9 equals 3, and then we'll add this 9. So far I've got 6x, I'm adding a 9 right there, equals 12 divided by 6. X equals 2. Now I have absolutely no guarantee that x is really 2. I won't know until I check. So back to the original. 3 square root of 2 minus 1 equals square root of 3 times 2 plus 3. Okay, so this is 3 times the square root of 1. Is it equal to 3 times 2 times 3 is 6, so 6 plus 3. So that's 3 times 1 equals the square root of 6 plus 3 is 9. So I've got 3 equals 3, and that one does check as well. So only after I check can I be guaranteed that that really is an answer and I don't have a no solution type of situation. Okay, let's go on to the next one. Okay, so we're going to solve an example 4. We want to square both sides. We've got a radical who's on a side by himself. Now this 4 is okay, so I'm just going to square that 4 also. So let's just go ahead and square both sides. Let's see how this works out. Okay. Alright, I'm squaring both sides here. Now remember, just like in the last one, this square is going to apply to the 4 and to the radical. So 4 squared is 16. Square root of 2x plus 9 squared is regular 2x plus 9. Equals, now x plus 8 squared is x plus 8 times x plus 8. I've got to write this twice so that I can multiply it all the way out. There's an addition in the middle of that square. So unlike this one where it's a product, it's 4 times, I can square both parts of that product. This is an addition inside of something. There's no square roots that are going to pop anywhere, so I need to make sure I really multiply that all the way out. So we're going to do our distributes here. 16 times 2 is 32. X plus, let's figure out what 16 times 9 is. 16 times 9 is 144. Equals x times x is x squared. X times 8, so I've got 8x. 8 times x, and lastly 64. Okay, we want to get everything, I've got a squared term, so I want to get everything on the side with a squared term, get it equal to 0 so that I can factor to solve. So I've got x squared. What we're going to have next is we've got, on this side we've got 8 plus 8, so 16, but we're going to subtract this 32 from the other side off, so I'm going to get 16 minus 32, or negative 16. Put my calculator away, but I can get it back out. 16 minus 32, so negative 16. Then we had 64, and we can subtract that 144 off of both sides, so we'll get minus 80. Okay, so I wanted to equal to 0 so that I could begin to factor it. So when I factor it, I'm going to start with x in each parenthesis because I've got coefficient 1, and I'll look for two numbers that go into 80 and add to 16. Okay, so things that go into 80. 80 and 5. Okay, but I would need to subtract those, so 5 and 16 would subtract to 11, so it doesn't work. Okay, so let's try 4. 4 goes into 80 20 times. 20 minus 4 is 16, so 20 and 4 will work if the 20 is negative. Okay, so negative 20, positive 4, add to negative 16, negative 20, positive 4, multiply to negative 80. Perfect. Okay, so now I've got x minus 20 equals 0. and x plus 4 equals 0. If I add 20 to both sides, this one gives me x equals 20. If I subtract 4 to both sides, this one gives me x equals negative 4. No guarantees that either one of those is right, so let's go ahead and check them both. I'm going to start by checking 20. So that's going to be 4 times the square root of 2 times 20 plus 9. Equals, and I have to check to see if that's equal to 20 plus 8. So I'm checking with 20. So that's 4 times the square root of 20 times 2 is 40 plus 9, that's 49. Equals 20 plus 8 is 28. So this is 4 times 7 equals 28. So that one checks. So 20 works. Let's try 4. Okay, so this one's going to be 4 times the square root of 2 times 4 plus 9 equals 4 plus 8. Okay, 4 times 2 is 8. 4 times 2 is 8. 8 plus 9 is... Oh, sorry, that was negative 4. I'm plugging in a negative 4. I was wondering why that wasn't going to work. Okay, so 4 times... negative 4 times 2 is negative 8 plus 9 is 1. Negative 4 plus 8 is 4. 4 times 1 is 4, so this checks. Okay, so both of them work in this case. It's actually very, very rare to have that happen, but both of them work. All right, let's try another example, and let's see what we can get here. Okay. The square root that I'm starting with right here is not by itself, so I am not going to start by squaring both sides. What I'm going to do first is subtract this 10. I want to get that square root by itself before I square both sides. So we're going to start with 3x on one side, I squared 3x on one side, equals x minus 6 on the other side. Okay, now that I've gotten the square root by itself, now I'm going to start by squaring both sides. So the square root of 3x squared is 3x equals, I know when I square the x minus 6, to square that, I write x minus 6 by itself twice, and I do x times x is x squared minus 6x plus 36. Right? X squared minus 6x minus 6x plus 36. Got to square it again, so we're going to get it equal to 0. So I've got x squared equals... or I've got 0 equals x squared minus, okay, 6 and 6 is 12, minus 3 more is minus 15x plus 36. Keep going, we got to factor this thing. 36 is 6 and 6, so that'll add to 12, so let's try something else. 36 divided by 9 is 4, 9 and 4 adds to 13, doesn't work. 36 divided by 3. 3 and 13 adds 16. Oh, I did 39. Oops, I meant to do 36. There we go. 3 and 12 adds to 15, so that pair does work. Both negative. So x minus 3 and x minus 12. Perfect. Those multiply to a positive 36 and add to a negative 15. So if x minus 3 equals 0, add 3 to both sides, x would be 3. And if x minus 12 equals 0, add 12 to both sides, x would be 12. I don't know yet if either one of those works. We're definitely due for an example where we don't have one working, but I can't tell which one it is, or even if it's both of them. It certainly could be both of them that doesn't work. So let's try. Let's plug the first one in. Let's plug x equals 3 in. So I've got the square root of 3 times 3 plus 10 equals 3 plus 4. 3 times 3 is 9, so square root of 9 plus 10 equals 7. Square root of 9 is 3 plus 10 equals 7. This one is definitely a no. So we see an example right here where x equals 3 just doesn't work, even though it looks like it works just fine. It does work for the squared version of the problem, but not for the original. Okay, let's test the other one. Square root of 3 times 12 plus 10 equals